If you want to find the input impedance at some distance from the load, you first plot the load impedance on the chart, then you can rotate it around the center of the chart by however many wavelengths you need to account for the length of the line. So for example, suppose you have load impedance ZL equals 80 minus J40 ohms, being driven by a feed line with characteristic impedance Z0 equal to 50 ohms, and you wish to find the input impedance at a distance of 0.3 wavelengths from the load. The first step is to plot the normalized load impedance, which is 1.6 minus J0.8. Adding a length of transmission line will not change the magnitude of gamma. It can only change the phase. So we can draw a circle of constant magnitude of gamma, centered at the origin, that passes through our plotted impedance. This circle represents the range of possible input impedances. No matter what length of line we choose to add, we will end up somewhere on this circle. And every point on the circle will experience the same reflection coefficient magnitude. To find out where on the circle our specific length of 0.3 wavelengths puts us, we will use the scale marked wavelengths toward generator and move along this scale by 0.3 wavelengths. So to start, let's find out where we currently are. We do this by drawing a line from the origin through the plotted impedance and reading off the current location on the wavelengths toward generator scale. I read 0.306. To this, we will add the length of our added transmission line, 0.3 wavelengths, which brings us to 0.606. Then we draw a line at the new length to find out where on the circle we ended up. But if you try to do this, you'll find that the wavelengths toward generator scale only goes up to 0.5. Again, the reason for this is that as you increase the length of the transmission line, the impedance repeats every half wavelength. In other words, adding or subtracting half a wavelength makes no difference to the input impedance. So instead of drawing a line at 0.6 wavelengths, we will draw a line at 0.1 wavelengths. At the intersection of this new line and the constant gamma circle, we can read off our new normalized input impedance, which is 0.675 plus J0.525. This corresponds to an unnormalized value of Zn equal to 33.75 plus J26.25 ohms. Again, let's check this using our equation for input impedance. We know that the input impedance is given by this equation, and if we plug in the values for this example, we get that Zn equals 31.75 plus J26.25 ohms. So again, the answer obtained graphically is very close to the answer obtained mathematically. So the steps for calculating input impedance at a distance from the load are, first, to mark the constant gamma circle corresponding to the range of possible input impedances. Then, ascertain the current location of the load on the wavelengths toward generator scale. Then add the desired transmission line length to the current location, and note that if your calculated sum is greater than half a wavelength, you have to subtract half a wavelength because the scale resets. Then, mark the new location on the chart and read off the input impedance value.